ahead and get started. So thank you everyone for joining. I'm sure people will be trickling in, but thankfully this is a recorded session. So I'll be sure to send out an email including today's recording. Also, I'll be sure to include ways that you can follow up with our speakers, Evan and Aoife. I'm so thrilled to have them here today. I've had the pleasure of watching their MasterClass presentation previously and learned so much. Can't wait to share this knowledge. They are both experts in the field when it comes to data science, AI, investing, all the things. I'll give a very brief introduction to both of them, but hopefully they can take time to go into more detail in their presentation about their work. But Evan Schnidman is a data and AI expert. He has a PhD from Harvard University, and he's built, mentored, invested in numerous AI-driven companies. He also founded and exited Prattle, which is an NLP company. And Evan has been widely published in macroeconomic and finance publications, and he's taught at Harvard and Brown. So very honored to have you here today, Evan, as an expert. Thank you. And he is accompanied by Aoife Manley, who is currently a data science graduate student at Georgia Tech. She's also the principal at Dasein Capital, which is an early stage AI VC fund. And the partners within this firm have exited a 1 billion AI data-driven company over the past decade. So we have some real tangible experience here before ChatGPT was a thing. I'm excited to hear the history there. Previously, she was a COO of a data analytics company, and she's worked in climate, tech, and impact investing. So very honored to have you both and to learn from you. I know that this is intended to be a series, so I hope that we can partner in the future to learn more. For those of you who are joining us, at the end, we always love to do a fun prize. It's one of our partners, her name is Sangeeta Verma. She's the CEO of a boutique gifting agency called Gift Suite. She sponsors these master classes and very thoughtful, handcrafted local businesses that are minority led. And so Aoife and Evan, I'll be sending you both one of those as a thank you for participating. And yes, we'll select one lucky winner at the end. So hang around. Other than that, yes, use the chat to introduce yourselves to each other. Use the Q&A, please, if you can, for questions, and we'll be sure to save time at the end to address those all. So without further ado, I will pass things over and just, thank everyone again for the opportunity to learn collectively.
Great. I'm just going to share my screen here. One moment while I get it full screen. And here we go. Present. Perfect. Thank you so much, Danielle, for the introductions. I'll skip over the introduction stage in our presentation. And I'll just tell you briefly about Dasein Capital. So yes, Dasein is an early stage AI ML fund, focused mostly in North America, but we also invest globally. And we have a keen interest in investing in companies solving impactful real-world problems. So with that, I will hand you over to Evan, who's going to take us through a history of AI briefly before getting into the discussion part of the conversation.
Yeah, thank you, Aoife, and Danielle, thank you so much for the warm intro here. As Aoife said, I don't think we need to go into our backgrounds too much. We can kind of jump straight into the topic, and please do put questions into the chat along the way. We'll try to address those and certainly have more of a discussion towards the end of this session here. But I'll try to kind of give a baseline here as to what is AI and really what does the evolution of AI look like over the last now 7 decades. And so really I think we start with the question of what is machine intelligence? What is AI? Really with the Turing test, named after Alan Turing, who essentially asked the question of, can we determine if a machine is intelligent based solely on the question of is it able to fool us as our interactions with the machine, we believe we're interacting with another human. It's indistinguishable from that human contact. And so that's the metric that has been sort of the guiding principle behind AI now for more than 70 years. And I think I should probably start by also saying, I asked the question of what is AI on a panel a few years ago, and 45 minutes later, the panelists couldn't agree in a 45-minute discussion as to what the definition of AI is. So don't expect a tight definition when you ask people that question, but everybody does harken back to this Turing test. Does this type of intelligence represent or seem like we're interacting with a human being? So if we kind of dig into the history of AI a little bit, it really starts with the question of, hey, where did this all start, right? There was a 1956 Dartmouth conference that was really widely regarded as the origin of AI, and not just the terminology, but really the beginning of scholarly research into developing systems that behaved like human intelligence or intelligence unto themselves. If we fast forward a little bit into the 1990s, many of us may remember when world chess champion Garry Kasparov lost to IBM's Deep Blue in a chess match. This was the first time that a machine was able to beat a human chess master. Now, this was largely done through brute force computing, not really through AI, but it was still a massive leap forward in terms of the ability of a machine to seem intelligent. Now, if we take another step forward into the 2000s, this is when we started to have things that looked or felt a little bit more like human intelligence, when Ken Jennings lost at Jeopardy to Watson, which was also an IBM construction. And the interesting thing about Watson is that still largely a brute force system, but was able to actually build off of some very important principles that tie to natural language processing and to AI more broadly, namely the ability to do named entity recognition. So named entity recognition is a notoriously difficult problem, where you're able to identify, is a machine able to identify correctly that this entity is one variant, not another variant. So knowing that the example of somebody like Steve Jobs at Apple, well, that's a different thing than a job at Apple versus a apple that you're going to eat, right? And a human being knows that, but a machine knowing that is actually a complex problem that Watson actually did solve for, and started to lead us down the road of using NLP as a real barometer for AI development. So now we move forward to 2016, and then there's a huge leap forward. And for those of you who aren't familiar with the game of Go, depending on what metric you use, Go is at least 4 times, if not more like several thousand times more complex than the game of chess. So developing a system that was actually able to beat the world's best Go players was actually much more complicated problem than designing Deep Blue to beat Garry Kasparov in the 90s. That's why it took almost 20 years. And this move to actually be able to develop AlphaGo, which was really revolutionary, changed the way that AI development really occurred in the next wave, which we're still sort of now in, and led us to the 2018 development of BERT, which was the first commercially available large language model. This was predicated on a paper that came out of Google in 2017 on the heels of the AlphaGo success. There's a team of scholars at Google who actually developed what are now known as transformers, which are a unique method of essentially teaching an AI system, and it's what all large language models are now predicated on. So where are we today? That's ultimately the question. And I think it's important for us to remember that AI is not just NLP, but that NLP, natural language processing, is where a lot of us interact with AI most acutely, most directly, right? A lot of us have played with GPT or Gemini or any of the other AI chatbots. But really, natural language processing has been around for more than 20 years now, and in many ways more than 30. And one of the things that's noteworthy is when I started working on NLP 15 years ago, it was basically good buzzword minus bad buzzword equals score, right? You had a limited dictionary, you pluck out the positive or negative words and just add everything up. That's not at all how NLP operates today. Now we're mapping linguistic patterns. We're understanding the relationship between words, phrases, sentences, paragraphs. We're training on literally billions of documents, hundreds of billions of documents. And really that's allowed us to go through not only from having supervised models that are tagged by human experts to actually having more complex models that are mapping linguistic patterns and tying how all these patterns relate to one another to actually create de novo knowledge or de novo output, i.e. we're actually able to have a system that automatically compiles disparate frameworks, disparate maps of language to create something that looks new. It's predicated on historical information, predicated on the inputs, but it appears to be novel. Unfortunately, for many of these systems, they're relying on a probabilistic response. They're reliant on what is the most likely answer to this question. If they don't have an answer, it will fabricate one. That is the hallucination problem. And so one of the examples I like to point to is several months ago now, right around when GPT-4 came out, a friend of mine who's a business school professor actually used GPT 3.5 to write a business school case about my first company, Prattle. And one of the things that shocked him and shocked me was he sent me the case and I took one look at it and said, I need to mark up everything here. These facts are all wrong. They were plausible. It was possible that those things were true. They had the amount of money we'd raised wrong. They had the timeline wrong. It was all plausible, but it just wasn't correct. He then reran the same query on GPT-4, and there were only two minor details it got wrong. It was clear to me what documentation it had actually ingested that changed that, but it's the value of having a lot more training data that it reduced the hallucination problem. The challenge is that both of those things were presented with the same level of authority as though they were correct. And there are several LLM providers, large language model providers, that are now talking about actually using a probabilistic system to demonstrate, hey, we believe this fact to be this level of accurate or that level of accurate. And really that helps solve for the fact that, hey, now they're training on more and more and more parameters. At some point, there's diminishing returns to additional data. And they know that, and they need to continue to have sort of a reliable system. And so Google has been working on a system that will tell you how accurate the document is in aggregate. I have it on good authority. There are some folks working on systems that will tell you a confidence interval on each individual fact as well. Although I think that might highlight some question marks about the accuracy of a lot of outputs. So I suspect that'll be a little while before we see those as commercially viable. So Aoife, I'll let you take over here and talk a little bit about what it is to invest in AI.
Thanks, Evan. Yes, so I'm sure a lot of us are interested in this aspect of how do I gain exposure in my portfolio to AI, be that in the public markets or in the private markets, investing via startups. I suppose what's first notable is that there's not just one category of AI companies, but rather there's this complex value chain and you can invest at different stages. So I think a lot of us are aware of, for example, NVIDIA, which represents the actual chip level or the hardware level. But yes, there are a lot of other levels that you can invest in. So for example, there's the foundational models themselves, which clearly take a lot of investment and a lot of engineering work to get right. And so we're not seeing so many players in those, but rather kind of these big concentrated bets. There are the data platforms then, all of these models have to ingest and use a lot of data. And so that's another wind. Developer tools, and then there's the application layer. And this is where we see a lot of startups playing in the application layer. So I'll talk a little bit about how we view this world from the Dasein perspective. So we have three main pillars that we like to look at when we're evaluating investments. Number one is domain expertise. So do the founders of the company have some specific insight into a problem? We have preference for legacy industries, for example. So it's all well and good to come and, take a model and throw it at a problem in an industry. But if you don't really understand the actual workflow and process of that industry, you don't understand the data, how it flows around the industry, and you don't understand the dynamics, then you probably don't have a good chance of making a truly defensible company. And I think a lot of people have fatigue now of evaluating solutions that don't really fit for their workflow. And so having that domain expertise and that insight is really, really beneficial in building a defensible company. We're also looking for drastically better solutions. And that might seem obvious, but so often people are coming with solutions that are marginally better or, solve a slight problem. Whereas we're looking for problems that have become tractable due to AI, meaning perhaps the problem couldn't have been solved before in any efficient way apart from just brute forcing through it. And now, because of recent developments in AI, it's a 10x, 100x, or 1000x improvement. We also like problems where there's a clear problem definition and an owner. So there's clearly a person who will have intent to pay money to solve this problem. And they have the authority to purchase, the authority to implement solutions. And the effort of evaluating and implementing a solution is worth it for them. Number three, an important area for us is data defensibility. So your solution is probably only as good as the data that it was trained on. So the question is, do you have access to proprietary data? Are you accruing some kind of valuable data asset? Because we're seeing the cost of compute come down and access to these incredible models become democratized. And so for a lot of companies, that defensibility piece is going to be in access to that proprietary data. So within this, there are two categories in that chart I showed you before of the value chain that we like to invest in. So one being workflow solutions. So things that make a serious business problem much easier for somebody in their workflow process. And number two, these more infrastructure plays that kind of support that more application layer on top. So we're going to talk through a couple examples of companies and how we viewed them or evaluated them, as I think that might be the most interesting way to do it. So I'm actually going to skip on to Market Reader. And Evan, how about you take this one? I know you've been a bit more involved with them than I have. Is Evan frozen or am I frozen?
I think Evan is frozen.
All right, no problem.
I do see his mute is on, which I've had my mute on as well. I sometimes do that.
No problem. I will just skip that one and come back to it later.
Awesome.
So here's a very interesting company that we can talk about. So this company is called Electric Sheep. Oh, I think Evan's back, but I'll do this one and pass it
yeah,
on.
apologies. I was just disconnected there for a moment, but go ahead and fill in on Electric Sheep. I will happily talk about Viridian and Market Reader in a moment.
Perfect. All right. So yes, Electric Sheep is a very interesting company. So in the film editing process, there is a step called rotoscoping, and that's a required piece for any other film editing to be done. And to date, this has been done by drawing by hand around every single figure in every single frame of a film in order to separate the actors or the objects from the background. And so if you can imagine a Hollywood film running maybe an hour or 2 hours, this would take hundreds, if not thousands of hours of manual work. And there was no way to automate this in the past. And so because of advancements now in computer vision and in machine learning, it is actually possible to train models to a high enough quality to do this almost instantaneously. So we're going from Hollywood productions having lags of weeks, if not months, waiting for this rotoscoping work to be done, to having it be able to be done basically instantaneously, which is quite amazing. So we invested in a company called Electric Sheep. The founders came from building technical VFX platforms for Netflix and Amazon and Apple, for example. So they have that domain expertise. They know how to build and architect platforms that are secure for the film industry, that are efficient, that fit the workflows. Data defensibility, they started by actually making exclusive contracts with Hollywood-grade film production houses, promising them a second of rotoscoping for a second of film, with exclusive rights to that footage, meaning that they accrued over $1 million of training footage, which is a massive advantage that other companies wouldn't have when trying to attempt to recreate something like this. And clearly a drastically better solution. I mean, taking it from, weeks and months of work to actually minutes or seconds. So this is an example of a company that really is applying a new development in AI to solve a problem that was so painful and so expensive, and making it drastically better in a defensible way. So I'll skip back now for you, Evan, and we can do a quick peek at Market Reader.
Yeah, absolutely. So Market Reader is a technology platform designed to explain the most common question in asset management and trading, which is, what the heck is going on with this company that I already own, or this asset that I see moving, right? Why is Apple up 5% or oil down 10%? What's going on? It's something that everybody who's invested in public markets has experienced at some point, saying, hey, I hold this thing, or it's on my watch list and I don't know why it's moving. And right now, the state of the art has been, okay, if you're an institutional asset manager, maybe you go ask your analyst to look on their Bloomberg terminal and then search through Twitter and look at the news and figure out what's going on in a combination of internal factor models, external news sources, external data sources, social media. Market Readers automated that whole process. They built out the factor models to identify, is this a sympathy move or a sector move, but also analyzing the news and social media information to identify what's being said that could be the driver or best explainer of what happened within the last 10 minutes. So this is all happening within a real-time window here. And what's wonderful about that is that they're then able to take that information, that factor model output, that news output, that social media output, and put it into a large language model and explain it in natural language prose. So if you're a financial advisor trying to answer a client question, you don't even need to craft the answer yourself. You can copy and paste or just send them the Market Reader output. If you're institutional asset manager and you want to ask the system further questions, you can dig deeper. If you're just a retail trader, you want to know what's going on, you get that quick couple sentence hit of information and can move on with your day. So it's just streamlined that workflow and answered those questions more efficiently. And Aoife, I can also talk about Viridian if you'd like to.
Sure.
And Viridian is it's about, as you know, both Viridian and Market Reader are Dasein portfolio companies. Full disclosure, I am a co-founder of Market Reader as well. That is a project that started as a consulting project for me, and we ended up spinning off a separate company, and then Dasein invested. And Viridian is a company I do some consulting work with. It's also a Dasein portfolio company that's built a machine learning based back tester. So when you're analyzing financial markets, when you're looking at building out a portfolio, one of the bigger challenges is, how do you backtest your data? How do you determine how this strategy would have performed historically? And what Viridian's done that's truly unique is actually build in machine learning capabilities natively into the platform. So you can test various machine learning methodologies on that data to see what is the best strategy for analyzing the information you've got to develop a trading strategy. So from a personal standpoint, I can say I spent a lot of time, energy, and investor capital building out a bi-directional long short-term memory model years ago. This was the state of the art in being able to use neural nets, which is a form of AI, to analyze complex information. We were using that to build a named entity recognition platform at the time. What's incredible about Viridian is they've built in tools like an LSTM, a long short-term memory model, literally as a part of a dropdown. So you point and click, it's natively integrated into your AWS instance, and it just runs. And so they can run a lot more permutations on your data, a lot more efficiently through genetic optimization, through LSTMs and other AI tools that allow you to not have to just do brute force computing and run so many iterations. You can actually find what's the best strategy much more efficiently and actually be able to then deploy that and run money on.
Awesome. So let's skip forward to the last example before we do a bit of a panel discussion. So this company is called Symmetry ML. So Symmetry ML has created novel data structures that basically enable us to share private data while completely preserving the privacy of the underlying data, at the same time maintaining analytical value. So what does that mean? I could have rows of data that correspond to patients' private medical data, and there could be multiple columns: age, weight, disease status, etc. So we changed this into a data structure that's really just, we call it the data elements matrix, and it's a combination of statistics and equations that capture relationships between the data items. This means that the underlying data, HIPAA and GDPR compliant, totally privacy preserved. You can't get back to it. So if I share a DEM with you, no way you can get back to the original data. However, the DEM captures enough information from the data that we can do really deep exploration and build predictive models on it as if we had the underlying data, which is really quite amazing. I mean, there are multiple different kinds of privacy preservation techniques, but they always have a trade-off between preserving analytical value, protecting privacy, and working efficiently at scale. And there hasn't really been an option that ticks all of these three boxes. And when we saw this company, we thought, wow, this is a true mathematical innovation that actually just changes the game for privacy preservation. And so this company's current application is in the pharmaceutical industry, because large companies, they run trials and track patients across multiple different countries. But there are countries out there where it is illegal to share your data outside of the country. So let's say you're Novartis and you're, spending billions of dollars developing a drug, and there are 1,000 patients in France, and you can't get a scrap of their data to submit to the FDA to show that this medicine is safe. And so that's one simple application of this kind of technology. Another one, for example, is actually enabling companies to use their data and actually sell those insights in a safe and secure way. So for example, if you're CVS, historically, there are, a lot of companies that would love to know, oh, if someone takes this drug, do they also take this other one? Which one do people stay on for longer, etc. There's a lot of interesting information in there, but they can't obviously sell that in raw format. And so being able to make a data elements matrix marketplace, and actually then people can researchers, pharmaceutical companies can pay to access that information, is again like a game changer, because there's been no safe way to share that information in the past, and now that's possible with these kind of innovations. So the ML piece here, there's also a platform built in where you can analyze these data elements matrices in a very simple way, and build amazing models hyper efficiently because of the way the data is compressed into these equations. So Symmetry is an amazing company. Definitely they have strong defensibility there, and a drastically better solution. I mean, in many instances, there was no solution before. So it's
worth note that more than 80% of the world's data is still in private hands, right?
Yes.
We think about the billions and billions of parameters that a model like GPT is trained on, and that's wonderful. But in reality, the vast majority of the world's data is actually sitting in private hands still. And so having a system like Symmetry that can mask that data to a place where it's still private, but actually use it for training purposes, has a number of valuable applications, not just in the healthcare space where it's most obvious, but in terms of building out more sort of specified digital assistants and workflow augmentation tools that are actually able to train on your own information, whether that be your own email or browser history or things like that. But actually being able to train on private data makes these AI tools that much more valuable.
Yeah, for sure. It's quite incredible, and it makes me think of how incredibly valuable the world's private data has become. Because when you think of all the models that are out there training on publicly accessible data, or even the crazy valuable contracts we've seen being created, for example, the New York Times signed a massive deal with, I think, OpenAI to allow them to train on their content. And so all of the value that's locked up in private data, and the incredibly valuable companies that you can build if you have access to proprietary data sets. Also quite interesting to think about.
Yeah.
Yeah.
Yeah. So Aoife, I think, I mean, I know we had a couple of discussion questions we discussed between ourselves, but I also want to make sure that folks know that they can submit questions here, and we'll happily, address those. But we have a few things we're very happy to talk about too.
Yeah,
Yes.
you guys let me know. There are, a few questions in the chat. I can start with one of those, or if you'd like to start with yours and we can save those to the end, you let me know.
Let's start with a couple ones I have here that I'd really like to cover, and then we will definitely open up for the Q&A.
Perfect.
So Evan, let's talk about ChatGPT 5. What are we going to see when that comes out?
I think this is actually an interesting. Before we even get to the question of what, how is 5 better than 4 or 4 better than 3.5, I think there's the broader question of, at what point do you see diminishing returns for more and more hyperparameter training, right? You can add, go from billions to tens of billions to hundreds of billions of documents, and yes, the model gets better and better, but there are diminishing returns on that. Maybe not if you're, NVIDIA and getting to run all this through your fancy GPU chips, but that's another conversation that we should have. But I think that when it comes to kind of the next generation of these models, you can think of it as an LLM today is roughly the same level of intelligence of a smart college graduate, right? They might be able to pass some very impressive exams and answer some general knowledge questions, but they're not going to be able to answer questions like an industry expert with 10, 20, 30 years of experience. The question becomes, what happens when we train on a lot more specialized data, whether that's in medicine or law or accounting or whatever industry it is. At what point does the system look like somebody with 10, 15, 20 years of experience? And I think that's kind of what we're moving towards, with more likely moving towards with GPT-5.
Definitely. I think that brings up another interesting question of what areas are interesting to invest in at the moment and where you can build defensible companies versus which areas are kind of, dangerous or unstable, meaning a new developments could render a company that's built there actually just invaluable. What are your thoughts?
So I spend a lot of my time talking to the venture community, right? So I run a fractional executives business where we slot into a lot of venture-backed companies. And so we work with a lot of venture funds, and we work with a lot of venture-backed companies. And every venture fund I talk to has a slightly different philosophy around this, but it largely boils down to a question of, do you believe in vertical solutions or horizontal solutions, right? The vertical solutions being the best AI for, okay, maybe it's contract law, maybe it's accounting, maybe it's radiology, right? There's really specific applications. The challenge with the specific applications is, as I just alluded to, at some point with enough training data, these larger and larger models are going to get as good or almost as good as the highly specialized trained model. And that makes defensibility challenging, especially if you're operating in a field that it is large enough for OpenAI or Google to go after building a model that is trained on that. If it's a large enough area, if the TAM is large enough, the total addressable market is large enough, they're going to train on that data. And so a lot of the really verticalized specific solutions, especially among LLMs, I think that's very hard to defend. However, the application layer, that gets interesting, right? If you can get something that people love using and are reliant on, that's important. To me, the bigger answer in all of this is, how do you get to the horizontal solutions? And that's where data comes in. And whether that's data infrastructure, which in many cases is the underlying technology that allows you to clean or process or store that data, or the data itself. And the analogy I've used for the last almost year now is, if AI is the engine, data is the fuel. And if you look at this from a financial standpoint, right, over the last century, would you have rather been invested in engine companies or fuel companies, right? Cummins makes great engines. They're a $50 billion company. Exxon, Aramco, all these other giant oil companies are worth more than $500 billion, right? So there's just an order of magnitude greater upside on being the fuel provider. And if you take that analogy further, there's also a question of you can't fly a fighter plane on low test gasoline. You need really high-end jet fuel. So at some point, the quality of the data matters too. And Aoife, you alluded to this before, right? Having whether it's a company like Symmetry giving you access to private data that's super specialized that allows you to train your model, or whether it's the ability to actually just get access to data that nobody else has, period, right? And so I think a lot of where I see upside in this market is not only the data infrastructure, but also the data itself, the data that can be used to train models.
Definitely. I also like to think about this in terms of, in a given industry, how fragmented is the data? How siloed is the data? How easy is it to access? I mean, there are certain industries where they've kind of grown up in this data-centric world, like the more internet, based e-commerce, etc., where all of the data is accessible. And then there are industries like healthcare, where data is siloed and fragmented. And on top of these kind of grungy old tech stacks, there's also all of the regulation and compliance, meaning that that data can't be easily shared. And so when you're thinking about building companies in those kind of spaces, it is not so easy to enter, but it's not so easy to recreate an existing solution, for example. When you think of all the pieces that you have to put together in a specific way, all the systems that you have to work with, and all of that data that you have to gain access to individually, if you can create a stronghold in those kind of industries, it's a lot easier to defend than, for example, in a much more fluid data-centric industry.
Yeah, and a lot of the work I've done over the last few years has been kind of exporting knowledge about the data world that we have in financial services into other industries. And one of the first projects I did after leaving the company that acquired Prattle, after leaving Liquidnet, I did a project for a large insurance company, helping revamp their data infrastructure. And ultimately, the biggest problem came down to the fact that they had scanned image PDFs of handwritten medical records.
Yeah.
And that was what their primary database was, scanned image PDFs of handwritten records. Now, this is actually a pretty straightforward problem from a technology standpoint. You use what's referred to as an OCR solution. So it's essentially you're using optical resolution to extract that data and populate a database. But they had never adopted one. They were still just manually doing everything with this data. And it's, now I look at that and think, that 4 years ago, at the time, they were saying, oh, should we do this? Should we not? Is it really necessary? Now you can't live without that kind of data. The value of this enormous set of medical records is clear. That even 4 years ago, it was an ambiguous thing as to whether or not they needed to clean up the way that those records were stored.
Yeah, it's amazing when you think about that delta or that difference between the technologically advanced industries, the tech that is like operational and deployed, versus these legacy industries. And that's really where a lot of my interest lies, on these industries that really affect our day-to-day world and life, like manufacturing or construction or energy generation. And how forgotten and how left behind they are compared to, for example, finance or e-commerce. And I did an analysis recently of the US Bureau of Labor Statistics data to see where are all the data scientists? What industries are they in? What are they up to? And it was quite amazing, the concentration of data scientists in, for example, finance versus in construction. There was almost a 1000x higher concentration, meaning like the ratio of data scientists to non-data scientists in the finance industry is about 1 to 100 or 1 to 200. And in construction, it was maybe 1 to 20,000. And I understand that, of course, that industry has more, physical labor. And of course, that ratio won't be the same. But when you think of the data being generated by 20,000 people working in an industry, and there's one data scientist to make use of that data, it really does show that there is massive untapped opportunity. And one interesting fact is that the manufacturing industry, which again has one of the lowest concentrations of data scientists, actually generates the most data of any industry in the United States of America. And so, yeah, these areas are quite interesting to me from an investment perspective.
Well, and I think from a labor flows perspective too, I was part of a team that put together AImaps.ai, which is a joint project with the University of Maryland and LinkUp, which is a jobs data company. And we actually tracked the geographic flow of AI jobs.
Yeah.
And one of the more interesting findings was that, everybody, as you'd expect, the metro area in the US that has the most AI jobs is the Bay Area. But number two was a surprise to everybody, which was Washington, D.C. And the D.C. area has the highest concentration, second highest concentration of AI jobs in the country, for a somewhat obvious reason if you think about it, which is the national security apparatus has actually been one of the fastest adopters of AI. And while New York was number three, it's noteworthy that just last week, I was at a quant finance conference with some of the top hedge funds in the world. And it was a closed door conference with some very impressive presenters, both from the AI world, but also among portfolio managers at some large hedge funds. And the gulf between the technology people were testing versus the technology they have in production was enormous. Everything is being tested. The most complex, the most intricate AI models are absolutely being explored at the world's top asset managers. Only 9% of the people in that room said that those systems were in production in any way. So that to me screamed that even in the most advanced industries, even in the industries that are adopting these tools, there's still a long way to go before you put them in production and actually, in the case of asset management, run money on them. In the case of medicine, there's a different barrier, right? It's not just, hey, am I going to increase my returns? Is this going to work? There's also the question in medicine of where does the legal liability rest? So there have been great AI radiology systems for decades now, actually. For over a decade, we've seen AI systems that can capably diagnose whether it's broken bones or cancer or anything else. But most doctors won't allow that to be the sole form of diagnosis, because if it's wrong, it's still your medical license on the line. It's still your malpractice insurance that gets stripped. You're still the doctor of record. And so it's an interesting question about when does our legal framework need to change for some of these tools to reach widespread adoption as well.
Absolutely. And I think we've seen that with self-driving cars. I mean, statistically, so much safer than humans on the road. And yet we have zero tolerance for error in them. And we have a very high tolerance for error in ourselves, even when the end product is more people, being hurt or killed on the roads. And I think the same will persist in those other industries too for quite some time.
Yeah, we just need, the regulatory world needs to catch up to the technology, and that's going to take some time.
And so from an investment perspective, then, do you think it's safer to avoid highly regulated industries because the regulation can be a business killer?
I think it's a question of, do you have high confidence in when those regulatory barriers are going to change, right?
Yeah.
And some of that, interestingly enough, some of that's at a state by state level too, right? And so I think, some of the questions around self-driving cars, we've actually seen municipalities and states treat those very differently than federally. And so that also then begs an interesting question about what's your TAM, right? How big a total addressable market do you need for this business to be viable as a scalable opportunity? And how long do you think it's going to take for that to change? I've done a fair amount of investing in highly regulated industries. I've invested in the cannabis space for years now, and watched how the regulatory barriers have come down. But that's a long-term investment strategy. If you're looking for a shorter-term investment, there's a lot of regulation around AI that needs to change.
Right. And then when we're looking at different geographies, I mean, for example, in Europe, we obviously have the European Union, which is quite conservative. And then we have all of the countries within Europe, which all have their own regulatory take. And so I wonder, will it make it even harder for companies to scale in those regulated industries in Europe and widen that gap? And also how, for example, China comes into that. versus the US, for example.
And is exactly where I was about to go. There's Kai-Fu Lee wrote AI Superpowers a number of years ago now, about the idea that essentially China was going to win the AI war, not the US, for a very simple reason, which is that they have better data. They have more of it, and they have better data because they have a more advanced surveillance state.
Yeah.
And because that data is centralized within the government, they can train whatever models they want. There's a lot less data sitting in private hands in China than there is sitting in private hands in the West, and that's just that is just a fact. And so the argument was they could have inferior models but superior data and have better results. Truth be told, they don't need to have inferior models. Most of the models that get developed by companies in the US or in Europe end up becoming commercially available or open source pretty damn quickly. So they get access to it right away. I think it begs an interesting question, not about sort of the regulation around technology, but the regulation around data. And to some extent, Europe's been much tighter on regulating data than anybody else, which all begs the question around privacy, right? If you have the ability to keep that data private, but train systems that are specialized to your use case, to your instance, that actually is probably the next advance in AI, is taking these large systems and then bringing in your private data as an overlay to make it more useful for you as the individual.
Yeah, absolutely. And that's why we're quite interested in that privacy preservation space. And also what can be like computed on the edge versus computed centrally. So not taking data up to some, compiling it in a central server, but rather actually running like inference on edge devices and being able to update models there too.
Yeah, I actually advise a company that their solution to the privacy problem is edge computing. So running all of the calculations on your personal machine, rather than ever having to have a query go out to a server. They do not run a server architecture.
Cool.
And it's an interesting solution. There are some limitations to it right now, but over time, I think it's clear that edge computing is going to be how a lot of organizations get comfortable with privacy, because at some point encryption just doesn't cut it.
No, for sure. So Danielle, I know that you wanted to keep some time for audience Q&A, so I'll pass it over to you now.
Well, thank you. Thank you, guys. This has just been fascinating. And I'll start with one that's been in the chat from a bit earlier. Zishan asks us, we've talked to over 100 enterprises and they all want AI, but are afraid of data leak, seeing OpenAI's past strategies. We've successfully built out an on-premises LLM. You can talk to documents and add your employees and team collaborate offline. Has the family office seen any concerns from enterprises like so, and are they even ready for adoption? I definitely have some thoughts on this, but I'm curious to hear what you guys think.
I guess I literally run into this problem this week with a client of mine that is, their compliance team said, we will only allow the use of Microsoft products, not even OpenAI, because Microsoft, all of their data already sits within an Azure instance, which is an interesting solution, right? Microsoft's been very smart about how they did this, where they run basically a parallel instance of GPT within Azure and let you sit within their walled garden, which checks the compliance box for a lot of organizations because they've already said, hey, Microsoft has access to all of our data anyway. I'm not saying that's a perfect solution. Your data is still sitting within somebody else's infrastructure. But I think people have more confidence that Microsoft is not going to be training off of their data than OpenAI. Whether that makes sense or not is a whole different conversation. But I think when push comes to shove, yes, this is a problem I think every organization is worried about. Is how much of our data can we send out? Are we using it, or is it just being used to train somebody else's system that could be commercialized to our competitors? Or and I think in many ways this is why so many people have gone to using retrieval augmented generation, so a RAG layer on top of a base LLM, because you can query a base LLM and then run the RAG layer on your own architecture instead of querying it out to the LLM itself. It's a heavier weight solution than just training, than sending off your data to be input into the LLM, but it does solve, to some extent, solve for that problem.
Fascinating. Yeah, and from my perspective, I definitely see family offices adopting the technology, but in all industries, there is that hesitancy. And so a lot of families I've worked with, they are trying to build kind of their own solutions. But I think everyone has recognized to stay ahead in this day and age, you do have to start adopting and finding those solutions, whether you build it yourself or, yeah, adopt something that exists. Let's see, from Vipin, with the talks of generative AI, what are your thoughts on more conventional predictive AI focused ideas and ventures, i.e. predicting future behavior based on past data?
I'll quickly jump in on this one. I mean, I think predictive AI is absolutely essential. If you're trying to predict whether or not I have a heart attack, I don't want you to generate something made up. I want you to give me a prediction based on past data. And so yeah, I think it's an essential use case. And I mean, I think perhaps the difference here is that we have had some strong predictive AI for quite a while versus the generative AI wasn't so strong in the past. And that's where we've seen recent developments. And so perhaps why there's so much excitement around Gen AI. But I wouldn't say it's the end for predictive. Evan, what are your thoughts?
No, I fully agree. I mean, I think you look at a solution like Viridian, and essentially the purpose of backtesting is to be able to indicate what the future could look like, right?
Yes.
And that's essentially that's not quite predictive, but it's bordering on it. And that's why you build machine learning or AI tools into a backtester, is to be able to then run those simulations and optimize for what is the likely go forward. So yeah, I think predictive AI in some sense is actually further along than a lot of the generative AI tools that we see.
And I think people have almost forgotten that predictive AI exists because this catchphrase Gen AI, I mean, you almost think that Gen AI is AI and that there's no other category. So I'm actually really happy with that question there, because I mean, predictive AI is basically what our world runs on. It's why Amazon know how much to stock based on previous sales trends. It's how we figure out what the weather is going to be like tomorrow. And we've been, we've been extensively using it. I mean, if all predictive AI models went down tomorrow, we definitely know that.
Well, and I think one of the interesting innovations in recent years has been the ability to run those models off smaller and smaller data sets too, right? This was an interesting challenge post-pandemic, that especially for retail products, consumption patterns totally changed. So I did a project recently with a coffee company. Turns out people's coffee consumption when they're in the office and not in the office is wildly different. And they were having trouble predicting essentially how much coffee people would drink and of what type. And therefore how much to stock, how much to buy. Coffee prices it's a volatile commodity, right? They have to be able to manage their supply chain. And being able to predict off of smaller data sets is actually extremely valuable in a world where you don't have that many quarters of data that look like the world today before you hit the pandemic period. And so, that's totally a predictive AI question.
Awesome. All right, we've got a long one. Aoife, what would the price of AI tools surge due to Russia and China's chips going under? Huxia's bankruptcy, fewer chips in the market, and fewer players in general. Is that what NVIDIA is now focused on mitigating by acquiring companies such as Dasein AI, Run AI in order to pool GPU power at the edge computing intersection?
Short answer is I actually don't think that NVIDIA's stock price run-up has very much to do with compute power. I actually think this is personal opinion. I actually think that we're approaching peak compute needs for a variety of reasons. Everybody, there's been breathless sort of paranoia around the idea we're going to run out of electricity to run these GPUs. We're gonna run out, the supply chain can't keep up with the demand for them. Yes, that's what caused NVIDIA's stock price to run up, and that production has obviously ramped up for GPU and demand has ramped up. The historical arc of technology evolution is pretty clear, that these tools, one, become cheaper over time, and two, we get better at utilizing less resources with more advanced technology. I'm not saying we're going to go back to a world where we can run everything on CPU, but I don't think we need larger and larger chips to run large data sets. There's a lot of people working on how do you minimize the data load on the compute, and so I think that NVIDIA's actually game is more around how do they layer on services on top of their hardware business, and I think they've done a masterful job of that. And if you want to value that company, I'm not sure it justifies the rapid rise, but I do think it actually speaks to where they see their business strategy going. They know that demand for these chips is not going to continue to rise at the pace it has.
I've been curious about that answer, so thank you. How should family offices perform due diligence on AI company investments? Great question.
It's Aoife, I'll let you start on that.
Interesting. I mean, honestly, I think having a good partner who understands the landscape is probably the best way. You don't want to be in the position that many people were in, perhaps in the crypto bubble, where they were investing because everything seemed to be, progressing in one direction, and then made bets that had no defensibility and had no intrinsic underlying value. And so I think when it comes to anything that's quite technological, I think having a partner who understands the technology and understands the market and how to commercialize, I think is invaluable. And I'm not just saying that because I work in investments. Yeah.
And I would emphasize one part of that in particular, which is it's not just a matter of understanding the technology, right? I think people overly index on the technology. It's understanding the market landscape of what else is out there and where's the market moving. Because I think about this from the perspective of somebody who had an enormous amount of concentration risk in running an AI company for 6 years, and then turning around and now working with dozens of companies in the space. I have a very different perspective today than I did 6, 7, 8 years ago, because I can see the forest. I am not just looking at one detailed tree, right? Mm-hmm. And I think having a deep understanding of the market and what else is out there, how it all interconnects, and what's working and what's not is invaluable.
So this is kind of a follow-on. Oh, sorry. Go ahead.
No, I was just going to add to that. And I think those kind of startup and business fundamentals still apply. I mean, you can have an incredible technology and it can be 10x better than what's out there. But if you're selling to people that don't have time to listen, that don't have the ability to make decisions, that aren't incentivized to improve things, perhaps their promotion track is just for not messing up. That's real. And we see that in the finance industry all the time. And then you're not going to get anywhere. If you're selling to people who are fatigued because everybody's selling to them and they don't have time to evaluate your solution, I mean, again, you're not going to get anywhere. And so I think, yes, that you have to be careful to evaluate the technology, but also not ignoring all of these kind of fundamental market realities.
Yeah.
So this was a bit of a follow-on to the question you guys just answered, but on that due diligence front, are you aware of third-party service providers that perform AI-specific due diligence?
I know individuals who do it on a project basis. In fact, I know individuals who do it also for venture funds in specific domains. I've actually done projects like that. Because there is so much domain expertise that's needed. I don't know that I know anybody who has a specific business doing it. Aoife, do you?
No, I'm sure they exist.
Right.
Yeah, but I'm sure if you have questions, you can email us directly, and we'll find you someone.
Yes.
Yeah,
I know,
sure.
and I am mindful of time. There are a lot of questions that we haven't gotten to. I'll read one more, but maybe in my follow-up, if it's all right to share your information, then that way participants can continue the conversation, because yeah, there's just so many good ones, and this has been just amazing. I guess, well, I'm like, it is 1:59. I should probably be conscientious of the fact that people may have 2 o'clock calls. So for those questions we didn't get to, we'll be sure that you guys can continue the conversation afterwards. Our winner today, I just picking at random, Jim Green, thank you. And we'll be sending you guys both a little thank you as well for participating. This, I mean, just has been awesome. It is a sector that is obviously of increasing importance in every single industry, but it can be so confusing and overwhelming, and the pace at which, so today's insight has been invaluable, and I've really enjoyed it. I know I can tell from all the enthusiasm in the comments and questions as well that the audience really enjoyed this.
Yeah, thank you all, and feel free to reach out with any follow-up questions. Happy to answer anything.
Yes, absolutely. Thank you, Danielle. It was a pleasure to be on with you.
Thank you, guys. We hope to do more in the future. Everyone enjoy the rest of your day.
Thanks.
All right.
Bye-bye.
Take care. Bye-bye.